Okay, question 9, and here we're supposed to use the binomial expansion to effectively expand this. Now what we need to do is we split this up into the square root of 1 plus x over the square root of 1 minus x to get separate expressions, which can then be written to powers. So square root is power of a half, and then finally we can then pull this up to the top to overall leave it as a multiplication of two brackets, but where the second bracket is to a negative power there. Okay, now we can do the binomial expansion on each of these two brackets. Now 1 plus x to the power of a half, 1 minus x to the power of negative half. Okay, and they're both already in the format we need for the binomial expansion. That's 1 plus something to a power. Okay, so first one then, using the binomial expansion formula, 1 plus nx, well n is a half in this case, and x is just the x there, and then plus n minus 1, which is going to be minus a half then, over 2 x squared, and then we could continue to x cubed and x to the power of 4, etc., but according to the question we stop at the x squared term there, so that will suffice. Okay, on to the next bucket then, 1 plus nx, so n being negative half, and x in inverted commas this time being minus x there. Okay, and then n minus 1 over 2 x squared, where x is negative x in this case, dot dot dot. And again we stop at x squared because there was no need to get anything higher than an x squared term. Okay, so tidy up each bracket first probably. So this is going to be 1 plus a half x. There we've got a negative, and that would be a negative a quarter on the top, divided by 2. Well, that's negative 1/8. Over here we've got 1, that's minus a half times minus x is plus a half x. Minus half times minus 3 over 2 is going to be plus 3 over 4, so plus 3 quarters there, divided by 2, that's actually then plus 3 over 8, and negative x squared is positive x squared. Okay, so then we're ready to expand in the usual way. So 1 times 1 is 1, 1 times a half is half x, 1 times 3 over 8 x cubed is 3 over 8 x squared. Yeah. On to the next term, so plus a half x times 1, half x times a half x, half x times 3/8 x cubed. Now that's 3/16 x, half x times 3/8 x squared. That's 3/16 x cubed, but that's going to be higher than we need. So that x cubed is a higher power than we need, so I'll cross that off straight away. Next one then, minus 1/8 x squared, minus 1/8 times a half x would be a minus 1/8 x cubed, but again that's already of a power which is higher than we need, so cross that off, and any future power like the x squared times the x squared be x to the power of 4, that's also going to be too high. Okay, so simplify that, all of that, so we've got 1 half x plus a half x there is plus x, 3/8 x squared plus a quarter, which is 2/8 x squared, then minus 1/8 x squared, that gets us to 4/8 x squared, which is the same as a half x squared. You can check that on your calculator, 3/8 plus a quarter minus 1/8 if you need to. And there we go. And that is indeed what we were trying to show, 1 plus an x plus a half x squared. Okay, 9 part B, and these are one of those sort of tricky style approximations that you get in year 2. It gives you the x value to substitute in, and it gives you what you're trying to get an approximation for, root 3. But if you actually stop and think about it, if you substitute 1/26 into the original expression given in the question, square root of 1 plus x over 1 minus x, does that then effectively just give you root 3? Well, we'll find out that it's not, but that's certainly what we need to check first. So the original expression is this. So then if x equals 1 over 26, we get 1 plus 1/26, 1 minus 1/26. And if you do that on your calculator, you'll see that that becomes square root then of 27 over 25, which is not 3, it's 27 over 25. But can we use exact square roots to then help siphon off a root 3 here? Well, we certainly can, because if we think about the numerator here, then so we've got root 27 over root 25. Sorry, splitting the overall surd into a division of 2 surds. Now, root 25 is clearly 5, so that's nice, and a nice whole number there. Root 27, well, if you were simplifying that using surds, you would say it's root 9 times root 3, and root 9 itself is 3, so that simplifies down to 3 root 3. So consequently, the original expression is equal to 3 root 3 over 5, or 3 over 5 times root 3. Okay, so when we substitute our 1/26 into our expansion, that's actually given us an approximate value for 3/5 root 3. With a little bit of rearrangement at the end, we can then isolate the root 3, or make root 3 the subject. Okay, so therefore we know that 3/5 root 3 is approximately equal to 1 plus x, which is now 1/26, plus a half x squared, so 1/26 squared. Okay, so if you tap that into your calculator then, it comes out as 1.039, etc. But let's keep it, since we've got it as a fraction there, let's keep it as that for the moment. So 1405 over 1352. So as I said, that's approximately equal to 3/5 root 3, and so therefore root 3 itself is approximately equal to 5 over 3 times this 1405 over 1352. Okay, so effectively multiplying what I've got on the screen here by 5 over 3, and we've got 1.732. And it doesn't tell us. I'll give you an answer in the form a over b, where a and b are integers. Sorry, it gives us says in the form of that. So that's not particularly helpful at that stage. Sorry. Let's just go back a step then. So if it wants it in the form a over b, according to the question here, look, in the form a over b, where a and b are integers. Easiest thing to do there then. We've got the 1405 times the 5. Well, that's 7025 on the top. And we've got 3 times 1352, which is 4056. Okay, and when we put in 7025 over 4056 as a fraction, it doesn't give us a simplified fraction, it simply goes straight to the decimal. So we've got to assume, it's a reasonable assumption, that then is the simplest form that we can leave it in.